Hey guys, in this tutorial I'm going to talk about everything in Blender's liquid simulation, Blender's 5.0. So this is the latest version in 2025, and so let's right into the video. Right now, first of all, I've got a cube, so this is going to be the domain of the liquid simulation. So maybe you are not familiar with these terms. Either way, I'll explain them when we go in. Now, first of all, I'll select my cube, and then if I go here into the modifiers and add modifiers, and then we have physics. Under the physics, we can see the fluid right here. So we can also get the fluid modifier. Now, if you're going to go here into the physics, we have a physics tab right here. And now if you go here, now we can see the fluid here as well. So we can select that. Now we can have the fluid properties right here. Now we can see the type. Then this is really important. Now if we go here, the drop down menu shows us 3 different types of fluid. Now so this is the one that I'm gonna go apply. Now we also have flow and effector, so I'll talk about these things later on. Now first of all, I'll apply the domain. Right now, when you apply the domain, I can see it turns to something kind of wireframe cube, and also we have another small cube, so I'll talk it about in a minute. But before doing that, now we're going to go here into the domain type. So we're going to talk about the liquid simulation. So this is a gas, so we can select and then we can choose the liquid. So now you can see it turns to a mesh again. In the older version, if you are in the older version, you may see the mesh is not checked by default. So in that case, you have to check it on in order to see your liquid simulation. So anyways, and then before dive into all these domain settings, we got plenty of things to talk about. I'm not going to go through everything. Actually, this is a beginner friendly one. So anyhow, I want to create another sphere right here. So I'll create and scale it a little bit down. So this is going to be my flow object. So I'm going to go here under physics and fluid. So then we're going to go apply a flow. Right now we have the flow options. So this is going to be a flow object inside of our domain. Now I'll select F2 and then I'm going to type in flow obj. So this is going to be my flow object and this is going to be my domain. Now we have a flow object and also a domain. Right now I'm going to select my flow object and we're going to go here into the flow type. This is smoke right now, so we have to change into liquid. All right, now you can see just after I change my flow type to liquid, my domain just disappeared and it is like fit into my flow object. It has not actually disappeared. Now you can see the domain is still there, and also we can see the domain is still there. What just happened is, so domain got the flow object data and it created the flow. Right now if I play the simulation, now you can see already the fluid is created, so you can see it is working fine. Now also if you want, you can hide your flow object and still you can see the flow is working because the domain has already taken the data of the flow object. So this can be done for multiple flow objects as well. So if we duplicate this one and I'm going to scale a little bit down and then maybe create another one right here, and if I play that, now you can see the domain is creating fluid from all of these flow objects. And also if I notice, now if I duplicate then one again, and then I'm going to go and place it outside of the domain, and let's play that. Right now you can see my domain boundary ends right here. So my last flow object is clearly outside of the domain and it doesn't create any flow. So the reason, because always your flow object or any object that has fluid is applied, it needs to be inside of your domain, right? Otherwise it won't work. You should keep in mind that all of your objects needs to be within your domain. So I'll delete this object and also a couple of other objects because we're not going to use that, and then I'm going to go back and I can play this. And right now you can see another cool thing, because it is creating this all fluid even though we have deleted flow object. That's also something you have to understand in this case, because the Blender is already baked out this liquid simulation. That's why I told you that even if I turn off the fluid simulation, it is still creating your fluid. There is a small fix to this. So if you select your domain and then if you go here into your cache data, now you can see the cache directory where the cache files are saved. Always you can change your directory if you want. And so what I'm going to do here is I'll change my value a little bit. It's not necessary to change the cache data here, and you can tweak any of the settings if you want to rebake your simulation. So I'm going to turn this one to 100 because my time is also 100. Now if you play this one again, now you can see it is working fine as before. Now if you go here into the flow object back again, and I'll have some of the settings. So I want to show you some of these important settings. Now we already know the flow type, but down below you can see a flow behavior. Now if I select that, now we have a couple of options, and we have three types, which is inflow and outflow and geometry. Right now we are in the geometry, but if I select the inflow, now what happens is simply it is creating your flow continuously. And now you can see my domain is filled up with the liquid. Now if I go here and select outflow, and if I go back and if I play this, it doesn't create flow at all. There's a reason for that, because we don't have any other flow object. Basically the outflow means it deletes some of the particles of the fluid. So in order to delete particles, we have to have a liquid. So that's why we need to have a one inflow or geometry type in order to delete, which means we need some flow inside in order to outflow to work, right? So I'm going to go back here and then set inflow. And if I go back, and now we can see my flow is just created, and then I'm going to go create another object, and then let's scale a little bit down and place it somewhere here, and then I'm going to go apply fluid again, and let's type to flow, and then I'm going to change this flow type to a liquid. And then right now you can see since my flow behavior is geometry by default, it is already created another liquid right here. So I'm going to change my flow behavior to outflow. Right now you can see if I play this, my liquid is supposed to be filling, and it's supposed to be creating liquid continually because my flow object type is to inflow. But since my outflow object is right beneath that object, it destroys or deletes the particles of the liquid. So that's why you can see there is no liquid coming out of this surface. It is continually creating, but it is outflow object continually deleting my particles. Right, so I think you got that one too. So I'll delete my outflow object, and then if I play that one again, so right now, as I told before, the blender has cached it out, so we have to tweak some of the settings, and we have to rebake it. Right now it is working fine. So last type of the fluid object is the effector. So I'm gonna go ahead and apply another cube, and then this time I'll make it a little bit thinner, and I'm going to place it somewhere here. So you want to make sure every single time your objects or the fluid objects are inside of your domain. So I'm going to select my new one, and this one is going to be effector. So I'll call it effector, and then we're going to apply fluid, and under that we'll apply effector. And now we can play the simulation, and right now you can see my effect is perfectly working, and it is blocked some of these particles, and it is affecting the liquid and acting as an obstacle to the fluid. Since this is a little bit confusion to understand, I'll make my flow object to geometry, and then we're going to go back here. If I play this, now you can see my effector is working fine. So I think you got the idea here. So effect is basically an obstacle, so you can place anywhere, and also you can use these kind of effectors to make some containers and hold your liquid inside. There are many more use cases with this. So I'll keep this setup right here, and since we have already talked about most of the things, most of the basic things, now we can jump to the core part right here, the domain. So basically the domain is like a cage, as I told you before. It's like a cage or a boundary where the simulation takes place. You gotta understand some of the most important parts right here. We're not gonna talk about all the things because this is a beginner friendly tutorial, and also it's really time consuming to explain everything right here. So I'll go back to my original state, and let's begin with the top part right here. Right now we can see a small cube right here at the corner of the domain. So this is called a voxel cube. Right now you can see a resolution division. This is really important, and the resolution division is exactly relative to this small cube. So which means it's like your quality of your liquid simulation. Right now my voxel cube is a little bit smaller one. Now that is because of my resolution right here, 32. If I increase that to maybe 64, and now you can see guys, my cube got smaller. It means that also my particle size is got smaller, and which means my fluid got much more smoother. Now if I play that again, now you can see it is also taking a bit of time than before because it has much more calculation going on right now. And also you can see my fluid is already much more smooth and much more fine. That's because my resolution division right here is large than before, double the size of the resolution division we had last time. So I'll go back to my original resolution because it is much more efficient to demonstrate the tutorial. So I'll keep it as 32. I think you got the idea here. So there's a really important thing with this resolution division. When you're creating a liquid simulations, you have to be careful guys, because you should not create a large gigantic domain at all. And because now if I create another cube right here, let me show you that. If I scale a little bit, maybe 3 times, right now you can see a 3 times scalar cube, and then I'm gonna apply fluid, and then we're gonna go here into the domain. So this is another domain. Right now you may remember that we have to change this one to liquid, and if I go back right now you can see I have another cube right here and another cube right here. So this is my previous domain and this is my new domain. If I play this right now, you can see even though I have one flow object, since my flow object is inside both of these domains are taking the data from the flow object and also the effector, so that's why it is acting as before. But clearly you can see if I close a little bit up, my second domain pixels is much more large and jaggedy compared to the first one. My first one is a little bit smoother compared to the second one. And also you can clearly see guys that my voxel size of the second domain is much more larger. It's actually 3 times larger than this one right here, because we got a 3 times larger cube. But if I select the domain and if I go here into the physics properties and under the resolution division, we have the same resolution division. Right here we have the same 32 resolution divisions to the smaller one and also to the larger one. So the resolution division is by default the same, but since the resolution division is small for the large one, it has to increase the pixel size to fit with this resolution division. When you create a gigantic domain, your particle size is going to be really high when you have a smaller resolution division. So in order to get the same quality, you have to increase the resolution division of your second cube, right? Maybe not 64, maybe we have to increase that much larger value. Right now you can see it is still large, this one right here compared to this one. And the problem with this one is when you increase the resolution divisions of the second one, it takes much more time and it always taking much more energy of your PC to render out. You can simply remember that the resolution, higher number of resolution division means higher number of calculations. So that's why you want to make sure if your simulation takes place in a small position or a small place, so you have to make sure your domain is just fitting that specific location or just fitting that small specific position, right? So you should not create gigantic domain that covers entire scene. That's really important point. So I'm going to delete my second domain. Then I'm going to close up to my original first one. So another important thing I want to talk about here guys, if I delete this one, and so I'll create let's say monkey head and scale a little bit up to cover up my all the object right here, and then I'm gonna keep it like this. So what if I apply domain to this monkey head? Now you can see, now if you change my domain type to liquid, since my domain is like a monkey head, the simulation will affect like this, and it will act like a shape of a monkey head. But it doesn't work like that. If I play this one again, right now you can see kind of weird situation because the monkey head was not like a cube, right? It is going spread throughout this and it's like a cube again. The reason because the Blender doesn't take every single shapes as a domain, it converts all these shapes into a boundary box. Since the bounding box of the monkey head is a cube, the domain is also a cube. That is something you wanna keep in mind when you're creating your simulation. Another really important thing guys, So you want to make sure your face orientation is also correct, otherwise you won't see any liquid simulation form. So let me show you that. So this is my only flow object. Now if I go here into the edit, and then if I shift N key on the keyboard, if I recalculate the normals to inside, and right now my normals are on the opposite directions. So if I try to play my simulation again, right now we have my monkey head as the domain, but if I play this simulation, you can see the simulation doesn't work because we had only one flow object, and it is incorrect in normals direction. So you want to make sure your normal directions are correct. So I'm going to shift N again and make it correct. So if I go here and play this again, right now you can see it is working fine. So I'll delete this one and I'll create another cube again, and scale it 2 times, and then apply the domain again and change this one to liquid. And if I play this, right now you can see it is working fine. So now we can talk about some of these liquid domain properties. So most of the time, guys, you have to keep your resolution division in a small number, like 32 works really well. And then you can tweak all these settings and you can finalize your liquid simulation. And then if you satisfy with your liquid simulation, then you can finally increase the number before rendering out. So that is a good practice that you can do most of the time. So another thing is the time scale. So the time scale is nothing but special, but you can increase the time scale and your simulation is going to be really faster. Right now you can see the simulation is really fast. So this doesn't change any physics, but it is actually changing the speed of the simulation. So I'll type back to 1, and now we have really handy settings right here. So this is CFL number. This is a little bit complicated for beginners. So physics calculations are happening in the slow simulations like frame by frame, but that is not the case most of the time. So actually the Blender, it calculates all these calculations in a time steps, right? So there can be multiple time steps in between one frame. So those are denoted right here as time step maximum and minimum number. So which means your one frame can have 4 time steps and the minimum number is 1. So CFL number is also related to these numbers. So lower the CFL number means your particles will move in a long distance in a one frame. Now if you have a higher CFL number, so what happens is your fluid simulations get a little bit jaggedy and low in quality. So I can show you that increasing the CFL number to maximum value, which is 10. Now if we play this one, right now you can see it is really jaggedy and really low in quality. And also it's really fast in calculations, by the way. So I'll undo that to my default value, and most of the time these values are working fine. So most of the time you don't need to tweak this CFL number or anything right here. If you increase in your CFL number, most of the time you have to increase your minimum number in the time steps. Now if you're reducing that CFL number, you have to increase your maximum number. So with that being said, let's jump into the second part right here. We have a grayed out section right here which calls scene gravity, but we can't change that. There's a reason for that. Now if you go here into the scene, and under that we have another gravity section, and then we can change your scene gravity. The scene's gravity is basically the whole gravity in your scene, right? It affects to the whole scene. Now if you want to change your gravity per domain, so you can simply uncheck this one, and then you can come over here selecting your domain, and you can come over here into the physics, and then you can see my gravity sections is appeared, and we can tweak the values, and then we can have a custom value per domain. So with that being said, guys, let's jump into the border collision sections. The border collision is also a really important part. For your domain, you have 6 faces always. So all these faces are denoted under the border collision. Now you can see front, back, right, and all these top bottom faces. Now, so what this does is simply if I turn off my bottom face, now if you go here into my first frame and if I play these, right now you can see my liquid is disappeared and it doesn't collide with my bottom face. The reason because there is no any bottom face of the domain. It just unchecking deactivate your bottom face. So you can do for all these steps, and right now we have no any collisions with the side faces. So let me turn on my bottom face again, and if I do like this, and I can see my side faces are hidden, and then the flow is no longer colliding with these faces, and it just disappearing like this. So for the rest of the tutorial, I'll keep these settings like this, and I'm going to collapse that, and then we can come over here into the liquid section. So the liquid sections is, now liquid sections has a lot more settings. Now you can have more control of your liquid simulation. Right now you can see a small checkbox right here in the liquid, so you can uncheck that or check that, but it doesn't change anything. It seems to be doesn't do anything. It still creates the liquid. It's not because of a caching issue. It is actually just the particle system. Right now, if I turn on my X-ray, right now you can see some of the particles inside of the mesh, which are actually moving. And also you can see different colors. So these colors indicating some of the values of the flow itself. So the bluish color is more stable particles, while much more green, and when it comes to red and yellow, those particles are much more violent and aggressive. Right now we have no any violent particles with this fluid simulation. So if you go here and turn it off, you just delete your particle system, that's all, right? Now you can go into the particle system right here, selecting the domain. Right now you can see no particles, but if you turn on this one, now you can see my particle system is again created. So this is just a particle system, right? So you can do most of the things as in the normal particle system right here. Even you can select some object, and then you can browse some object, and then you can, for example, if I create a cube and place it somewhere here, maybe scale a little bit down and apply the scale. And if I go here and select this object, now you can see my particles are really small. Maybe we can scale this one a little bit. Right now we have a little bit visible cubes, and then we can go here into the physics. Under the physics, now we have mesh, and if I deselect the mesh, right now you can see my cubes are forming. Now if you go a little bit closer, right now we have a cube falling down simulation, but this is a little bit trickier one, so you have to do a couple of things in order to disable your domain and render out your particles only. So this is not a tutorial for this one, and if you want this kind of tutorial, put a comment down below and I'll do a complete tutorial later on maybe. So I'll go back to my particle system, and I'm gonna delete my particle system totally. And if I go here into the physics, and then I'm gonna turn on, and then you can see it is no longer cubes, right? It is also turned back to the normal particle system. And then also I'm going to delete my cube right here. If I go back, and then I can play with this, and I forget to turn on my mesh, and if I turn on my mesh, it is working as before. Now you can go here and we can see that simulation method. So this is a really important one. And now we have two types of simulation methods, flip version and APIC version. The flip version is more aggressive simulation method. So if you want more aggressive liquid simulation, you can always keep that to flip version. If you want more honey-like, more stable version, you can select the APIC version. So if I play the APIC version, now you can see it is much more like honey. It is not exactly like honey, but you can see if you turn on the X-ray viewport, now you can see your particles are really calmed down, right? It is really slows down and much more stabilized. But now if you change back to flip version, actually that flip and APIC, the settings under that is pretty much the same. But if you change to flip version, you can see a one setting just appeared, which is flip ratio, right? The flip ratio means how aggressive your simulation is. So you can go all the way up to 1, and which gets you the more aggressive fluid simulations. If you closely look at your particles are really aggressive with this value at a 1. And if I go all the way to 0, which is pretty similar to APIC. Actually, it is. I noticed that it is way more stabilized than the APIC itself. Like you can see, it is more stabilized. Right. So I'm gonna go back to my original strength. I don't really remember, but let's type in something 0.9. Right. I'm gonna go back, and now we have a couple of options. So I'll talk about these things real quickly. So we have system maximum value, which means how much of particles we have within our domain. Right now it is 0, which means we have unlimited particles. But you may think that we have a small number of particles, we can even maybe count that. I don't know. It is not that, because we have a geometry right here under the flow object, which means the domain is only creating a flow that can fit inside the flow object. It is not continually creating. So if I turn this flow object back again to inflow, if you can remember, inflow always creating your flow continually. Now if you go back, the flow is creating continually. Already I turned off my sidewalls. Since that is the case, my particles are deleting since when it hits the sidewalls or disappearing them. So I can go here into my settings and border collisions, and I'm going to turn back on. Now if I play this simulation again, right now you can see the particle volume is always going up. But to demonstrate that, the system maximum, if I type in something 150, let's see what happens. Right now we have 150 particles. Even though we can calculate, I can definitely say that there are 150 particles here in the domain. So that's all about the system maximum. Even though we have set our flow object to inflow or creating the fluid continually, since my system maximum number is 150, it stops creating flow when it hits to this number. So I'll set it to 0, and also I'll uncheck these values, and also I'll change my flow behavior to geometry back again, and then we can continue on. Right. So now we have the particle radius. If you increase that, what happens? Particle itself going to be really scaled up, and if you increase into something like that, you can see a really jaggedy and clump up. I don't know how to call it, but you can see that the particles are really large and kind of flowing like a clumpy. So if you want something low polyparticles or liquid simulation or something like that, you can definitely use this particle radius right here. Also we have a couple of other options now. So I'm not going to talk about everything because this is going to be really complex, and then we have particle maximum and minimum numbers. So these are like how many particles that can have per voxel cube. And so you have 16 per voxel cube and minimum of 8 per voxel cube. Right now we have sampling, so you can increase the sample number, so you can see that your particle size or the volume is getting increased. And also we have randomness, which means that how random your particles are behaving. Right now we have a couple of other options as well, but most importantly we have the diffusion. If you want more thicker fluid, you can turn on the diffusion. You can check the diffusion. So if you go back here and if I play that, nothing happens, because most of the time the diffusion, these values are not working properly if you have a small fluid simulation. But if I turn the exponent value all the way to 0, we can see my flow simulation much more honey-like, really viscous. So exponent value is a much more affecting value under the diffusion. So you can get back to the 5. So the exponent is like the negative value of the viscosity factor, right? So if you have really low exponent value, which means higher viscous, and if you have higher exponent value, you have a less viscous flow. So I'm going to type in 6 again. Right here we have under the diffusions a high viscosity solver. So if you check this on, the fluid simulation is much more thick, like a cream. Right now you can see the fluid simulation is much more thicker and it falls like a cream. And also we have a strength value, so we can also increase that value, like maybe if I type in 10, and you can see the flow is barely moving. So you can check this high viscous flow if you want to honey like really thick or so on. And also you can change your exponent value if you want to play around with your simulations viscosity. So I'm going to turn back to my original state, just unchecking this diffusion. So we already covered the settings and pretty much most of the part in the liquid. Forget about the particle system and mesh. Actually the mesh is all about, you can, as a beginner friendly tutorial, I'm not going to talk about these things. The particles is also, we have a couple of options like foam, bubbles. If I go here into the X-ray viewport, now since these all things are turned on, if I go here into the particle system, I can see different types of particle systems are created. Like before the liquid particle systems, you have full control over these particle system as well. So these are different types of particles, so you can add different objects and like that. So you can see forms and everything. If you want to create something like waterfall or something, you can use these particles and play around with these particle systems and add different objects and effects, and you can kind of get some cool effect. So since the tutorial is getting really long, so I'm not going to talk about all these things, so I just tell you guys that what happens exactly in the particle section. So I'll uncheck these things, so we already know what the mesh is about. So I'm going to collapse the liquid as well. So if I go here into the cache sections, guys, we have a cache folder. We can browse your cache, and also we can set up a folder if you want to cache out to a specific location. So you can create another folder for cache out maybe, and we can accept that. As you can see, my simulation data just lost because I just changed my path of the cache. So we have to bake it again, right? So basically the baking or real-time baking is just done by the Blender itself if we do change some of the settings under the domain. So we can also see the start and end values. So those are, I think, really clear, because now we have playhead in the 1 frame to 100 frame right here. So that's all the things right here as well. If you bake this one, it bakes out from 1 to 250 frames, right? It's baked in 250 frames, even though we don't have that much of frames. So that's why you want to make sure your frames right here, or the end frame, is exactly as the end frame on your timeline, which means you don't want to bake out unnecessary cache, right? So under the type right here, we have a couple of options, replay and all. The replay is the one we are having right now, which is always the Blender's default cache in out system. So when you tweak some of the settings, the Blender, it is automatically cache it out again. But if I go here into the all, my cache is just changed, and right now we have a bake all button. So this is a little bit different one, because even if I go back to my first keyframe and play these simulations, it doesn't work like before. The reason because that the type is all. So we have to manually bake this one. So if I bake it all, now you can see the baking fluid is going on here. And right now the system is baked to my directory. Now if I play the simulation right now, you can see the simulation is working, is still fine as before. But now if you go here into the settings under the domain, you can't change any of the settings as before. The reason because right now the cache data is fixed to this file. You can't change any of these settings under the domain. And still we can change some of the display viewport display settings, because these are not affecting our physics simulation, just a representation. So that's why these settings can be changed already. But we cannot change any of other settings, right? So if you want to change settings, so you have to free it all, and then we can change some of the settings and you can bake it all again. So most of the time the type all is done when you done all this stuff, change all the settings, and if you finalize your simulation, and then you can increase your resolution division, and then you can bake all as I did before, right? So that's all about this type of the cache. So I just want to have my real-time caching, so I'm going to change my type to replay again, and I'm going to collapse the cache as well. Right now I have the same as before. So since that's the case, we've come to the end of this tutorial. So I'll finally talk about the field weight. So this is something really common field when it takes all these physics as a whole. Now you can see the gravity and all forces and everything here. So the field weight is basically how much influence that has to the simulation or the physics of the scene. So now we can increase, the most obvious one is the gravity, so you can reduce the gravity influence. So now if you go back here, and then if I play that, right now you can see my flow is falling really slower, because my influence of the gravity to this simulation is really low. Maybe we can reduce the gravity's influence totally to 0. Right now you can see when I play that, simulation doesn't work. Also we can change different influence values, like which means like we can have multiple influences. I'll real quickly show you how things working. Like, and if you add a force field, maybe we can add a wind force field. If I rotate that to 90 degrees in this directions, and maybe we're gonna take it somewhere like that, and if I play this simulation right now, you can see my flow is just drawing to the other directions because of this wind right here. So I'm not going to talk about all the settings right here under the force field, but now we can understand that all these simulations are affected by these effectors. So that's the thing. So what I wanted to show you guys, so if you go here into this effector, the field weight, right now you can see a force field, I think that's the one. So if I drag this one a little bit lower and if I play this one again, right now you can see my influence is getting low. I think this is not the one. I'm not sure about that. Maybe, yeah, this one, the wind one. So I'm sorry about it, but if I reduce the wind force influence, and then we can see that my flow is flowing, and there's a little subtle movement because the influence of the wind is really low. Now you can increase that, then you can see there is a little bit of force into this direction, right? So that's pretty much it, guys. So I think you got something all about the latest liquid simulation in Blender 5.0. And so if you got something from this tutorial, please like the video and subscribe to my channels if you haven't already. So with that being said, I'll see you in the next one.